Okay. So before we proceed with our class today, so I would like to remind everybody to mark your attendance through Putra Blast. Please mark your attendance through Putra Blast. Okay. So this is so this week we proceed with this one, bivariate statistic analysis. So bivariate, the name by so means that it involves the analysis of two variables. Okay, analysis of two variables by two variables, one IV, one DV. Okay, this is our LO. Okay, identify at the end of the session, students are able to identify the two types of analysis to determine association between IV and DV, between independent variable and dependent variable. So then you are able to determine requirement to run the Pearson product moment correlation and Spearman rank order correlation. So basically, there are two types of analysis to determine association between variables. Okay, which is we have the Pearson product moment correlation or PPMC and Spearman rank order correlation. In some circumstances, you also may use chi-square. Chi-square pun is part of the analysis that can determine the correlation. But that one for the categorical variable. Okay, but this one we focus on PPMC and Spearman rank order only. Okay, and then at the end of the session, so you are able to run the analysis in Ibm Spss and then report the result according to the 6 APA style, or the latest one is the 7 APA style. Okay, so these are the summary. So in general, these are the summary of bivariate analysis that involve the analysis between two variables, X and Y. X is referring to our independent variable, Y is referring to our dependent variable, X and Y. Okay, for categorical, if let's say you have the categorical variable of IV and DV, okay, and then for example, you have two categories for DV and two categories for IV. So the analysis that you can use include Pearson chi-square, Fisher's exact, and McNamara test. Ini contoh Tapi kita tak cover. We are not going to cover everything, but this one is just for your knowledge. Okay, just untuk tahu sahaja. Okay, other than, at least you know that other than PPMC and Spearman rank order, there are also another correlation analysis that are possible for categorical variables. Okay, and then if you have the Y or X, IV or your DV are larger than two categories, then you can use chi-square or mental Hansel analysis. Okay, mental Hansel analysis. Okay, and then for example, next one, if you have the continuous DV, dependent variable, but your IV is categorical. Okay, then if let's say your Y is normal, this one we divide into the data distribution, either it is normal or non-normal. If your DV is normal, meanwhile your IV consists of two categories, then you can apply the two independent sample t-test. Okay, you can apply either the PET sample t-test or sign rank order t-test. Either one lah, dua-dua boleh. Okay, and then if you have the non-normal DV, okay, because your DV is continuous data, but if let's say it is non-normal, then you can apply the Wilcoxon rank sum, Wilcoxon ranking analysis. Okay, and then next one, if you have your your DV is normal, but you have more than two categories, your DV is more than two categories, then you can run the one-way ANOVA. Next one, okay, if your DV is not normal, but you have more than two categories for your DV, then you can run the Kruskal-Wallis test. Kruskal-Wallis test. Okay. Next one, if you have both continuous DV and IV. Okay, so if let's say your your IV and DV normal, then you can run the scatter plot. Okay, you can run the scatter plot analysis, or you can run the simple linear regression or Pearson product moment correlation or Spearman's correlation. Okay, but if your IV and DV are not normal, then you can run the Spearman correlation. So this is the division or the illustration of bivariate analysis available. Okay. Okay. So the correlation, so in general we use to describe the strength and direction. So why we use correlation? Because we want to describe the strength and direction of the linear relationship between two or more variables. Okay, so this is the purpose of using correlation. So correlation does not determine the cause and effect. It just determines the strength and direction, strength and magnitude of the relationship. Okay. So the correlation is designated by small r. Okay, by small r. Okay, so the range of r value ranging from +1 to -1. Okay, which is the smallest correlation referring to the smallest correlation refer to what is the value of the smallest correlation? Zero. So 0 indicate that there is no correlation. Plus minus just indicate the direction of the relationship. Either the relationship is positive, meaning that IV increase, DV increase, or IV decrease, DV decrease. That one considered to be the positive relationship. Negative relationship is referring to the inverse relationship between IV and DV. One increase, another one decrease, or our IV increase, our DV decrease, or our IV decrease, our DV increase. Okay. So the direction again, the plus minus just referring to the direction of the relationship. Okay. So because if we reflect into from our first statement here, okay, correlation ni we are interested in the strength. Strength ni we are referring at the number, magnitude here. Okay. Meanwhile, direction ni reflect the plus minus. Okay. Direction ni plus minus, strength or magnitude ni referring to the number. Okay. Okay, plus ni dah. Okay, so +1 ni designates a perfect positive correlation, so in which it is rarely happen lah to have a complete or perfect +1 correlation. Meanwhile, the -1 designate a perfect negative correlation. Okay. So these are the 3 example of the direction of the relationship. So first one ni, for example, of a positive correlation. The second one diagram ni, the second diagram example of zero correlation. Because as we see the distribution of the dotted line tu, it goes around the figure. And then the third figure ni indicate the example of a negative correlation. In which if we look at the direction of the dotted line tu, it's it start from top to the bottom. Okay, it's located downward. So this one you already learned during your statistic class, which is the equation for Pearson product moment correlation. Okay, R ni you dah belajar ni, saya cuma recall balik je. Okay, so Pearson product moment correlation is developed by Carl S. Pearson and then it is measured by RS. RS ke RP ke R saja? What is the designation of the correlation, Pearson correlation? Ke R saja? Saya lupa dah. Anybody remember?
R saja.
R saja. Okay, so it's measured by R, or we know or known as correlation coefficient, perkali korelasi. Okay. Okay, so Pearson product moment correlation is a parametric statistic. What is parametric statistic? It's not Paralympic, it is parametric. What is parametric statistic?
Normally distributed.
It is it require the data to be normally distributed. Okay, so the purpose of using Pearson product moment correlation is to determine the relationship between the two variables, which is IV and DV. And then sometimes, if let's say you are testing on the multicollinearity, for example, you are not interested in determining the relationship, but you are interested to determine either there are multicollinearity issues in your data set. Ada juga, possible juga Okay, next one. The requirement to run the Pearson product moment correlation, your DV must be either interval or ratio. Meanwhile, your IV also must be interval or ratio, meaning that your data for both IV and DV must be in continuous form, continuous data. It cannot be in categorical. Okay, so the assumption that required to run the Pearson product moment correlation include the score for both IV and DV must be normally distributed because it is a type of parametric statistic. Okay. And then the case represent a random sample from the population. So meaning that we select our sample ni randomly from the sample. Okay. Okay, so what to cover in this topic? So we are going to cover on the Pearson product moment correlation correlation coefficient, and in which we are going to describe into two things. First, descriptive part, which is we extract the R value and then determine the direction in terms of positive relationship, negative relationship, or no relationship. And based on the R value, we also can determine the magnitude of the relationship, in which we will use the Guilford rule of thumb as a guideline to interpret the value, the magnitude of the relationship. Okay, for the inferential part, so we are going to learn on example of a null and research hypothesis for correlation. We report the R value, determine the alpha, make decision and interpretation, and lastly, present and report our finding according to the APA style. Okay, so these are the expectations. So you are able to extract the correlation coefficient from the table, from the correlation metric table. You are able to describe the nature of relationship. When we mention about the nature of relationship, please remember two things. Okay, the first thing is the direction of the relationship. The second one is the magnitude of the relationship. Dua benda sama macam what we learned during our statistic class. Okay, when we want to describe the nature of the relationship, please describe into two things. Okay, that include two elements of direction and magnitude. And lastly, the hypothesis test. Okay, dah. Okay, so last time when you attended your statistic class, so you represent your hypothesis for Pearson product moment correlation analysis by using rho, #not rho equals to 0, or alternative hypothesis might be 3 options: rho not equals to 0, rho larger than 0, or rho lesser than 0. Okay, so but to be more practical, so we try to transform or translate our hypothesis into written form. For example, there is no correlation between IV and DV. Okay. Another example, there is no correlation between intention to live and job performance, for example. Okay. And then our research hypothesis, there are 3 options. Tiga. Okay, there is a significant correlation between IV and DV. Okay, so when we mention about hypothesis, please remember that there are three possible types of writing our hypothesis. Either it is one tail or two tail. Okay, one tail ni dia ada dua lah. Okay, apa tu? One tail ni meaning that you indicate the direction of the relationship. Either if there is a positive correlation or negative correlation. Okay, so for example, there is a significant and positive correlation between IV and DV, Another one, there is a significant and negative correlation between IV and DV. Okay, or you want to indicate your hypothesis in two-tail, in which you do not indicate any direction, okay, on the relationship between your IV and DV. Example is there is a significant correlation between IV and DV. Okay, so to determine which one to be chosen in your dissertation writing, it must be based on your literature review. Okay, it shouldn't be from your personal opinion. Make sure you refer to your literature. What does they say previously according to your study, according to your variable. Okay. Okay, for the descriptive part, describe the nature of the relationship. Okay, again, we describe the nature of the relationship into two things. The first one, direction, either positive or negative based on the symbol plus minus. Okay, and then we determine the strength or magnitude of the relationship by using the Guilford rule of thumb table. Okay, so this is the table of Guilford rule of thumb table, in which please remember the value, the R value indicated in the table. Lesser, if the R value lesser than 0.2, it is referring to negligible or almost no relationship. 0.2 to 0.4, low relationship. 0.4 to 0.7, moderate relationship. 0.7 to 0.9, high relationship, and larger than 0.9, very high relationship. So please remember these indicators. Okay, another indicator that also can be used to interpret the R correlation coefficient value is Cohen rule of thumb. Okay, Cohen, other the option, the alternative for Guilford rule of thumb. So this one is quite simple compared to Guilford rule of thumb. Okay, so 0.1 indicate weak relationship, 0.3 indicate medium, 0.5 indicate high relationship. Sebenarnya you can use either one, either you want to use the Guilford rule of thumb or Cohen rule of thumb, depend on you. Okay. Okay. Ni tak apalah kot. Ni senang je So correlation ni senang. Positive, negative, no relationship. Okay. So now, again so correlation coefficient ni perkali korelasi range from -1 to +1. So in which 0 indicated the smallest value of correlation, with all non-existent of correlation, and 1 indicate the perfect correlation. Okay, so in terms of steps of hypothesis testing, so there are 5 steps. The first step, you need to mention or state your H0 and HA, extract the statistics, statistic, which is our coefficient, set your alpha, make decision, and lastly make your conclusion. Okay, so in terms of hypothesis, these are the 3 options. First, you state your null hypothesis. Okay, when preparing your dissertation, it is advisable for you to mention both null and research hypothesis, null or alternative hypothesis. But I'm not sure why recently I see that most of scholars, they just mention the research hypothesis. Even though we know that it is understandable that the null hypothesis will be something against the research hypothesis, but I strongly recommend you to mention both in your research proposal or dissertation. Okay. Okay, so to extract the test statistic, first we need to run the analysis in Ibm Spss. So please open your ERS5951 dataset. Let me know when you are ready. Done?
Yes.
Okay, mampus laju semua. Okay, so to run the analysis, the Pearson product moment analysis in Ibm Spss, first you click analyze, click correlate and choose bivariate. Analyze, correlate, bivariate. Then next one, in bivariate correlation box, you choose the two variable, either your IV and DV or possibly your IVs. Depend. Tapi ni boleh pilih, you can choose your IV and DV. Okay, PB mean and task mean, or you can choose SN mean. Done? Okay, then make sure, okay, under the correlation coefficient, you tick for Pearson, and test of significance, it depends on your research hypothesis. Either it is two-tailed or one-tailed. Okay, make sure this one test of significance ni you tick according to your the direction of your hypothesis for research hypothesis. Okay, check your research hypothesis. Either it is one-tailed or two-tailed. Okay, and then you tick for flag significant correlation. Okay, so then click OK. Belum lagi. Sorry. Next one, you tick for option. Click option. Okay, for option, you have the option to get the mean and standard deviation for your IV and DV. Tick this one je, mean and standard deviation. So then click continue. And then lastly, click OK. Done? Done. Okay, so do we have a similar finding, similar result? Sama tak? Okay, the first descriptive table will indicate the mean, standard deviation, and number of sample available in your data set. So mean under the descriptive statistic ni should be similar to the mean value that we run during our EDA analysis or our frequency analysis last time. Should be similar result. Same goes to standard deviation. Sama je. Okay. And then next one, the correlation table. So correlation table ni please pay attention. So how to read the table? Some of you might be able to read the table already lah, but some of you, for those who are having trouble, so please pay attention. Okay, so in this table you can see there are few numbers. Okay, they locate 1, 60. Okay, but you read this table according to rows. Okay, first correlation coefficient. Okay, so this one you go by table and by rows and columns. So task mean. So the relationship between task and task mean and task mean. Okay, so this one our IV, this one is our DV. This one is our IV, this one is our DV. Okay, so if you can see this table, they repeat the same values. Okay, 0.34 here similar to 0.34 here. So it should be similar values. So you just cut the values from one. You can choose either you want to read the value at the top or the bottom, up to you. Okay, they are just similar values. They just report similar thing, but twice. Okay, so if let's say you want to read the values from the top, so then you close the bottom one. So that you do not confuse. Okay, so Pearson correlation equals to 0.341. And then we have two flowers here, two flag ni, flag. Okay, so meaning that our R correlation coefficient equals to 0.341. 6041. Okay, and then there are two flags here. Okay. Okay, the significant value is 0.0. Significant totally referring to the significant value. So the result is significant at 0.008. If let's say you set your alpha at 0.05, meaning that this is significant or not? Significant or not? Okay, our significant value lesser
No.
or larger than 0.05?
Oh, 0.5.
Smaller.
Smaller.
So since it is smaller, so significant or not?
Significant.
Significant. Okay, so 60 ni reflect our sample size. That's it. So the value that we need is only the Pearson correlation coefficient and significant value. Okay, but if you aware, the two flags here already indicated that the result is significant. The two flags here. So then you can see what does it mean by the two flags. Two flags it means that correlation is significant at the 0.01 level for two tail. So if let's say it is significant at 0.01, automatically it is bukan. Betul lah. So automatically it is significant at 0.05. Okay. So you can choose either you want to report the two flags or you want to cut the two flags and report the significant value, up to you. Okay. But again, what we want to report is the Pearson correlation coefficient and the value here, the alpha value. Okay. Here. Here. Okay. Next one. We determine our alpha, either 0.05 or 0.01. Okay. And then to make decision, okay, when we making our decision, there are only two options. Either we fail or reject our null hypothesis. That's why I said that it is important for us to indicate our null hypothesis in our dissertation, because later on the decision is based on rejecting or failing to rejecting our null hypothesis, not accepting our research hypothesis. Okay, the conclusion is based on our our null hypothesis, not based on our research hypothesis. We are not saying in our conclusion that we are accepting our research hypothesis. Tak ada kita tak cakap macam tu. We just say that we reject or fail to reject null hypothesis. Okay? Okay, so based on our findings earlier, since the significant value 0.008 lesser than alpha 0.05, therefore we reject the null hypothesis. So we can conclude that there is a significant correlation between task-oriented copying and philanthropic behavior. So this is a brief decision that we made according based on our finding. Okay, so now based on correlation R equals to 0.341, what we can interpret. So then we refer to our Guilford rule of thumb. Okay, so this is the values. Okay, 0.2, 0.2 lesser than 0.2, 0.2 to 0.4, 0.4 to 0.7, 0.7 to 0.9, then larger than 0.9. Okay, so R equals to 0.341. It falls within the range of 0.2 to 0.4. So it indicates a positive relationship because there's no symbol, there's no negative symbol in front of 0.341. So we know that it is a positive correlation. And in terms of magnitude of the correlation, we interpret according to the Guilford rule of thumb. So it falls within the range of 0.2 to 0.4. So we can interpret that there is a low relationship between task-oriented copying and philanthropic behavior. So this is the example how to present your findings in APA table. So table 1, correlation matrix between task-oriented copying and philanthropic behavior. Okay, so this is the example of the table. Make sure the table is single spacing. Okay, so this is the example of interpretation. A Pearson product moment correlation analysis has been conducted to test the relationship between task-oriented copying, the mean equals to 4.43, standard deviation 0.51, and philanthropic behavior, mean equals to 3.86 and standard deviation 0.48 among Malaysian volunteers. So results indicate that there is a significant positive correlation between task-oriented copying and philanthropic behavior, which is the correlation coefficient equals to 0.341, significant value equals to 0.008, and then according to the Guilford rule of thumb, the relationship considered low. So this is how you can present your finding. Any question? Any question? Kan senang je, petik jari je. Okay, next one is Monroe correlation. Okay, so it is a type of rank order correlation analysis. Okay, the purpose similar to, it shares similar purpose with Pearson product moment correlation, in which we use this type of analysis to determine relationship between two rank order correlation. Or okay, we use this type of analysis if let's say our IVs and DV do not meet the requirement of normality. Sama ada it is based on rank order ataupun data kita IV and DV tak menepati data normal. Okay, data kita tak normal. So therefore we can consider to use Pearson product moment correlation. Okay, to use Pearson rank order correlation, the requirement either okay, our DV and IV are in ordinal form, okay, or our DV and IV are interval or ratio form, but it is not normal. Dua pilihan, dua requirement. Kalau let's say kita ada data dalam bentuk ordinal for both IV and DV, or our IV and DV are in interval or ratio forms, but they do not meet the requirement of normality. So then you cannot use the Pearson product moment correlation. So then as an alternative, you can consider to use the Spearman rank order correlation. So in terms of coverage, is similar with Pearson product moment correlation. Sama. Pun sama. Exactly similar. Just the requirement je different Saya boleh laju lah. Okay. Identify and describe. Okay. So different with Pearson product moment correlation coefficient, in which it is designated by R. So for Pearson for Spearman rank order correlation analysis for Spearman rank order coefficient, we use RS. S ni indicate the Spearman. Okay, so describe the nature of the relationship between the two variables in terms of the direction, positive or negative, and strength or magnitude of the relationship. Okay, ni tak apa, boleh laju. Okay, so similar to Pearson product moment correlation coefficient. So the correlation coefficient for Spearman rank order also range from 0 to 1, which is 0 indicated the non-existent of the correlation, and then 1 indicated the complete or perfect correlation. Okay, but in terms of the value, it range from -1 to +1. So negative and positive just indicate the direction of the relationship. So to read or to interpret the magnitude of the relationship, we can also refer to the Guilford rule of thumb table. Okay, similar to the previous one, or we can also refer to cohort. Okay, sama dua-dua pun boleh. Okay, ni saya skip. Ni sama je Okay, so now go to our data set to run the analysis in IBM Spss. Okay, to run the analysis, you just click analyze, correlate, and bivariate. Similar to the earlier step, analyze, correlate, bivariate. Okay, in the bivariate box, correlation box, okay, please choose a categorical variable. For example, education and salary. Education, salary. It is in ordinal form. Education, ordinal, salary, category pun ordinal. Dan saya tak buat lagi hari ni. Education already in ordinal form. For salary, am I too fast? Dan?
Okay, done.
Dan. Okay. So then after you select the two variable of education and salary category, then under correlation coefficient, you tick for spearman. Okay, for the test of significance, again, it is depending on the on your research hypothesis, either two tail or one tail, and then flag for significant correlation. For option, we do not need any means and standard deviation, but it is not applicable because it is in ordinal form. Okay, so we can skip this step. Click continue and then click OK. So this is the finding. Do we have similar finding? Okay. For a Spearman rank order correlation, there is no descriptive table because it is not possible to compute the mean and standard deviation for ordinal data or for categorical data. So that's why there is no descriptive table. Okay. Okay, in terms of reading the table, it is similar to the Pearson product moment correlation table. Okay, the finding is in matrix. Okay, so the top one and bottom one report similar thing. So you just block one side ni. Okay, so correlation coefficient RS indicate that the RS value equals to 0.710. Okay, meanwhile the significant value equals to 0.00. Okay, and the sample is 60. Okay. Yeah.
My result was the correlation is 0.700 and not 0.710.
0.700. I thought it is depending on the level depending on the interval that you use for your level salary category. Ataupun saya memang dah buat memang by default it's already there. Which one?
Saya pun 700.
0.700.
00.
Yes, doctor. I got 0.070.
Kenapa saya dapat 0.710 Hold on lah. Apa betul lah tu. Tapi betul lah tu, mungkin saya guna data lama ni.
Doktor, kita guna data yang dah siap screening semua hari tu kan? Yang dah bersih kan?
Yes, betul. Kita guna, we use the data that already been screened and then already went through the EDA process. So if you do have any apa tu outliers, then you should delete first lah. Betul lah, correct. It is 0.700, betul. So this is the output. So supposedly you got the 0.700. Betul Saya punya tu slide lama lah tu. Okay. Saya guna this one So you all guna data yang you all ada. Okay, so 0.710 indicates positive and high relationship between level of education after we compare with the Guilford rule of thumb table. Okay, and then meanwhile significant P first. Okay, first we refer to the points at the significant two-tailed 0.000 in which it is lesser than 0.05. So it is indicate that the result is significant. So we have the significant association between the level of education and salary category, salary. Okay. And then based on correlation coefficient 0.710, okay, indicates positive and height relationship between level of education and salary. Okay, so this is the brief description of the finding. Okay, so next we determine our alpha, either 0.05 or 0.01. Okay, so then we make our decision. Okay, so since significant R 0.000 lesser than alpha 0.05, so therefore we reject the null hypothesis, indicated there is no relationship between the two variables. Okay, so we conclude that there is a significant correlation between level of education and salary. Okay, so in terms of the nature of the relationship as indicated earlier, so since the RS value correlation Pearson, Spearman rank order correlation coefficient 0.710 indicates, okay, after we compare with the Guilford rule of thumb, it falls within the range of 0.7 to 0.9, indicating the height relationship. So we conclude that there is a positive relationship and height relationship between salary and level of education. Okay, so in terms of table presenting our finding in the table. Okay, so table 1, correlation matrix between level of education and salary. So the representation similar with Pearson product moment correlation. So the table should be in single spacing. Okay, so this is how to report your finding. A Spearman rank order correlation analysis has been conducted to test the relationship between level of education and salary received among Malaysian volunteers. So results indicate that there is a significant positive correlation between level of education and salary. R equals to 0.710, significant value equals to 0.000. According to the Guilford rule of thumb, the relationship considered to be high. Dah, senang je. Any question?
Teacher, this week and last week, a slide you have not upload in the class.
On the way. I will upload within this
Okay.
week, inshallah. Okay?
Okay, thank you.
Okay, so we proceed with the next one. Sebenarnya dah habis dah untuk silibus ni, kita lah acu ni. Okay, next one is simple linear regression and multivariate linear regression analysis. Okay, but for those who want to run the Pearson product moment analysis or Spearman rank order correlation, you can run the analysis of more than 2 variables at one shot. Okay, tak semestinya you all run one by one. Okay, you can run, if let's say you have 3 IVs, 3 independent variables, and then 1 DV, you can run the analysis simultaneously. You boleh run the analysis simultaneously. Tak perlu buat satu-satu. Okay, unless you in your study you just include 1 IV and DV. Okay, that one just now I just give you the example of bivariate analysis. But if let's say you include more than 2 variables in the correlation analysis, it becomes the multivariate analysis lah. Okay, more than 2 IVs. Okay. So this is the LO. Identify at the end of the session, students are able to identify the types of analysis available for prediction and test for effect purpose. Determine the requirement to run simple linear regression and multiple linear regression. Okay, and then run the analysis in Ibm Spss. Report the findings according to APA style. Okay, so simple linear regression as what we learned during our statistic class. So it is the extension of the Pearson product moment correlation. So it shares similar characteristics, similar criteria or requirements with Pearson product moment correlation. Okay. So the purpose of using the SLR is to determine the relationship between 2 variables. Okay, generally between IV and DV. Okay, so in a simple linear regression, we just use 2 variables, 1 IV and 1 DV. That's why the name is simple linear regression. Okay, so another purpose of using SLR is we want to determine the effect or influence of IV towards the DV. Okay, IV, the influence or effect of the IV toward the DV. And then lastly, we want to make prediction of DV based on IV. Okay, so the requirement to run the simple linear regression, make sure that the scale of measurement for variables for both IV and DV are in interval or ratio scale of measurement. Okay, sama macam Pearson product moment correlation. Both IV and DV must be in interval or ratio scale of measurement. Okay, for example, the regression between age X and CGPA Y. So age in ratio, CGPA in interval. An example. Okay, for non-metric or categorical IV, it must be transformed into dummy variable, in which we assign the variable to 0, 1. Ini nanti ada session lain lah for categorical IV. It is only possible to run the simple linear regression if you have the categorical IV, but we must transform the categories into dummy form first before we can run the analysis. Okay. 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 So the assumptions to run the simple linear regression, first we need to make sure that the independent and dependent variables are bivariately normally distributed in the population. So make sure that both IV and DV met the requirement of normality. So only then we are able to proceed. Then next one, the case represent a random sample from the population, meaning that the sample has been randomly picked from the population. Okay, what to expect first? We are able.
Sorry, Doktor.
Yes.
Sorry, ni just nak tanya lah. Kan dia punya requirement is a simple sampling. If we use convenient sampling, does its effect significantly or not significantly if we use convenient sampling to do SLR?
Okay, basically in general when we use convenient sampling or other sampling then in which non-random lah. Okay, simply said, if you use non-random, so you are unable to use statistic, basically. Okay, you are unable to use statistic. So you are only able to use apa dia?
Eksperimen.
Statistic. Okay, we go, if let's say we go to the basic last time we learned that statistic ni come from statistic come from sample, right? Betul.
Betul, sampel, betul, sampel. Okay.
If population, parameter, betul.
Betul, parameter. Betul.
So meaning that basically if you do not use random sampling, you cannot use statistic. So statistic ni include all the types of analysis lah. Itu basic principle dia. Can you mute apa ni Apa ni? Jimbo, can you mute? Okay dah. Okay, so basically basic principle you cannot use statistic, but there are also books and there are also suggestion that you are still able to use the analysis, but you need to mention all the limitation. Maksudnya limitation, among the limitation, the findings only applicable to the sample, to the studied sample only. If let's say in your study you use 86, then only to that 86 only. That limitation lah. Because
tapi memang kita statistik kita memang kata only on that group only kan. In many paper pun kan kita tak cerita they can be a
the purpose, first kali, the purpose of having sample is we want to make conclusion from the sample to the population.
Betul. Okay.
So before we are able to make the conclusion from sample to the population, so we need to apply certain sampling technique when we select our sample, which is we have to use, it is compulsory to use random sampling.
Okay.
Kan itu the main purpose of conducting quantitative study, which is we want to make generalization from sample to the population. How we are able to make generalization from the sample to the population? So we randomly pick the sample. We cannot conveniently pick the sample. So we need to randomly, so to avoid the bias lah. Okay. So then if let's say you do not run you do not use the random sampling, so therefore by principle you cannot use the statistic sebenarnya. Tapi ada juga scholars yang kata you still able to use statistic but with some limitation in which you need to highlight that one the finding is only applicable to sample, not to the population. So in which in your study it just limited to that 86 sample. Kalau contoh, for example, in your study you just include 86 sample, so it just applicable to that 86 sample. With sebenarnya with a lot of other limitation. Maksudnya ada
so
question.
it cannot be generalized lah. It cannot be generalized towards the population.
Cannot. Totally cannot. And even your finding tu can be questioned. Even your finding tu, sebenarnya finding tu akan timbulkan banyak persoalan sebenarnya, banyak keraguan. Sebenarnya even tu 86 tu pun, 86 sampel tu pun kita tak tahu dia applicable ke tak.
Although the sample size besar kan, for example when you use convenient, we can have a huge punya sample size to reduce dia tu kan.
Cannot.
So still same juga.
Still cannot replace. Still cannot replace. Sebab random sampling ni is one of the significant principle in quantitative study. Dia memang kena pilih sampel tu, kena pilih sebab larger sample does not mean that we select our sample correctly. For example, I want to choose the most performing student. Contoh. Okay, then I conduct my study on Monday. In which on Monday ni, for example, Mahfuz didn't come because due to headache. So I conveniently choose my sample. Is it fair?
No.
Itu dia punya alasan. Itu the justification in quantitative study lah. Dia tak sama dengan kualitatif. So kena bezakan dua tu. Kualitatif lain, the intention, interest lain. Kuanti lain, kuali lain. Okay?
Because it's quite difficult kan to get the random sample to
Yes,
follow the
in
random
some
sample rules
cases.
tu
Betul?
difficult.
In some cases it's very difficult, but it's okay. If let's say there are no study in the area, it's okay. At least we provide the superficial finding on the area to attract more interest on the area in the future. At least kita ada dulu superficial finding dulu kat bawah dulu, tak apa. Faham
Faham. Thank you.
Okay.
Doktor,
Yes.
doktor nak tanya kalau even if we use simple random sampling kan, dia kena dia kena balance between gender ke? Macam it has to be equal female and male ke? Kalau let's say the population has more female, so kalau masa kita ambil sampel, it happens that to be more female, dia okay kan? Atau we have to use like certain technique to get equal male or female?
Okay, if let's say gender tu becomes a very significant indicator in your study, then you need to try apply a certain technique so that you are able to get a balance ratio lah between gender tu. They're not necessary balance number, tak semestinya, but ratio according to your population. Kadang-kadang contohnya dalam populasi kita women lagi banyak daripada lelaki contohnya, tapi in reality saya rasa lelaki lagi banyak kalau tengok statistik. Shockingly. Okay, cuma kita tengok ratio. Kalau lah let's say perempuan tu lagi banyak 3 kali ganda, so then kita reduce lah sampel kita tu, maksudnya in terms of bilangan perempuan 3 kali ganda lebih banyak daripada lelaki. Guna ratio pun it's okay, not unless itu pun kalau kita consider when if let's say your gender tu becomes an important or crucial element in your study. Kalau dia tak ada gender tu, you do not highlight anything on the significancy or significant effect on your study, then tak semestinya. Okay?
Okay, thank you.
Any other question? Okay, so what to expect? So first we are able to derive the regression or prediction equation, and then you proceed with the hypothesis testing. Okay, by producing the regression model, identifying the regression model, identify the R squared and R value. Okay, R squared, what is R squared? Capital R.
Coefficient determination.
Coefficient of determination. Okay, coefficient of determination. What about R? Capital R? Correlation of, dia sebenarnya multiple correlation coefficient. Okay, but the value is similar with correlation, Pearson correlation coefficient. Okay, the value sama je. But in simple linear regression, we still run the analysis between one IV and one DV. Okay. Next one, you are able to read the slope, kecerunan. Okay. Okay. So this is okay. So in simple linear regression, so there are two important elements. So you are able to identify the B1 and B0. B1 is what is B0?
Y-intercept.
What is B0? Constant. B1? B1 is the slope. Betul. B naught is constant. B1 is the slope. Third. Okay. Recall balik. Sikit je ni saya sentuh ni. Okay. Ni tak apa laju. Okay. Ni best fitted line. Tak apa ni. Tak apa, laju.
Tahu.
Apa dia?
Tak tahu nak minum apa.
Tak tahu.
Kelayu je. Pulang. Nanti.
Apa dia tu? Amira Adrina. Amira Adrina tu cakap apa tu? Okay, tak apa ni, laju sikit. Okay, so when we use a simple linear regression, so first we need to identify the B1 and B0 from the output. Okay, so this is the prediction equation, the basic prediction equation for simple linear regression. So in which y equals to B0 plus B1 x1. Okay, y is our dv, y is our dependent variable, B0 is the constant, B1 is the slope, x1 is the value for x. Okay. Okay. So this is the illustration. So B0, what is B0? Constant, or the other name is the value where the straight line touch the y-axis. Okay. B0 is the value where the straight line touch the y-axis. That one is referring to B0. So B1 is the slope, kecerunan. Okay, kalau if we may recall, during our secondary school we learned about theorem Pythagoras. 3 squared plus 2 squared, square root of 3 squared plus 2 squared equals to 5 slope tu. Itulah theorem Pythagoras tu. Okay. Okay, so y predicted values of y-intercept, slope. So interpreting prediction equation based on a given prediction equation, you can determine or indicate the influence of IV on dV. Okay. So for example, y equals to 1.007 plus 0.75x. Okay, so for every 1 unit increase in x, y will increase by 0.75 unit. So this is how we can interpret the prediction equation. Y hat equals to 1.07 plus 0.75x. So for every 1 unit increase in x, y will increase by 0.75 unit. Okay. So the amount of increase or decrease in y is based on B1, slope, based on slope. Okay. For inferential part, ini tak apa, laju. Okay, first, this is last time what we learned in our statistic class. To state the simple linear regression hypothesis, we just state as H0, y equals to B0 plus E1. And then our research hypothesis, y equals to B0 plus B1 x1 plus E1. Okay, but in practical, okay, we can mention our research null hypothesis as the regression model does not fit. Salah ni. Ini for, oh sorry, this one for overall model. Okay, this one for overall model. Okay, so the regression model does not fit the data at alpha 0.05 or 0.01. So this is for overall model. Okay, and then HA, the regression model fits the data at alpha 0.05 or 0.01. But for individual influence of IV towards the DV, we need to indicate another hypothesis, which is the individual hypothesis lah. Okay, tapi yang ni untuk the overall model. Okay. Okay, so now to run the hypothesis, to run the analysis in Ibm Spss, now proceed with your data set. Okay, click analyze, click regression, and click linear. Okay, analyze regression linear. Analyze regression linear. Okay, in linear regression box, you choose your DV as PB mean. Choose your DV as PB mean. Dependent variable. And locate under dependent. PB mean, locate under dependent. And then for independent, you choose task mean. Then, okay, for method, there are a few methods, but for this step, we just focus on enter method. Enter method. Okay. Next one, click statistics. Click statistic button. Under the statistic box, you choose under regression coefficient, you tick for estimates. Okay, and then tick for confidence interval. Under level percentage ni, locate 95%. Okay, and then tick for model fit. Tick for model fit. Okay, then click continue. Okay, now go to option box. Okay, by default, they use probability of F default kan? Betul? Use probability of F default. Then include constant in equation, exclude cases listwise. Click continue. Then click OK. Okay. Forget about our finding first. Let's proceed on the regression method. Enter method that I mentioned just now. So enter method ni, if you aware, there are five methods under the methods just now. Perasan tak? Hold on.
Prof Bas ajar 3 je.
Tahu. Saya tak ajar semua. Saya pun tak ajar semua juga sebab yang semua tu kompleks.
Doktor, dalam writing kita tak perlulah sebut kita guna method mana ke? Kena sebut juga kita guna enter method. Walaupun enter method tu automatically digunakan dalam SPSS.
Okay. Sebenarnya in actual, if you mention the types of method that you use, it is more convincing. Sebenarnya methods tu dia is supposedly in alignment with our theory. The strong theory, the stronger the literature review that we have, the more tendency for us not to use enter method. Enter method is the most convenient method actually. That's oriented opinion. This one. Okay, so this one, so we have enter, stepwise, remove, backward and forward. So enter method ni is a method where we enter all variable at one step. Meaning that when we enter this one actually applicable when we have more than one IVs in our analysis. Kalau let's say kita guna simple linear regression because we have only one IV, so memang nak tak nak satu IV tu je lah yang kita masuk. Right, during the analysis tu. Masuk tu maksudnya when we run the analysis tu, we enter all the IVs at one step. Okay, itu enter method ni maksudnya if you have two IVs for example, when you run the analysis, you enter both IVs in the IV column, IV box tu. Okay, faham Maksudnya kita run sekali. Okay, stepwise method ni, it is a combination of forward and backward procedures examine each variable for entry or removal. Maksudnya kalau stepwise method ni, we are looking for the combination which variable should be entered first and then which variable should be entered later. Kita nak tahu which variable is the most influential variable, which variable is the least influential variable based on stepwise ni. Okay, kalau remove method, variables in a block are removed in one step. Maksudnya kalau remove ni, kita remove variable tu kalau let's say the variable tu does not have significant influence on our DV, then we remove. Okay, the system akan automatically remove. Kalau backward ni, variables are entered into the equation and then sequentially remove. Okay, kalau backward method, first we enter all the variables, all the IVs, tapi dia akan sequentially remove. Okay, for example, we have 4 IVs. Okay, and then at the first analysis ni, okay, that it is identified that one IV does not significantly influence, then dia akan remove. And then they will run the second analysis. Second ni, then kita identify that the third IV tu does not influence the DV. And then dia akan remove lagi. At the end of the day, dia akan tinggalkan the variables that yang betul-betul influence the DV. Sebab kadang-kadang in social science research, even though we include 4 IVs, for example, but sebenarnya it is possible that the relationship between the fourth IV towards the DV ni sebenarnya it is connected to the third IV. But after we remove the fourth IV tu, we can see that the third IV does not significantly influence the DV. Kan, sebab itulah social reality. Dia tak ada satu DV sebenarnya yang directly influence the DV. Dia sebenarnya saling berkait. Itu dia punya method lah. And then forward method enters variable at a time depending on whether they meet statistical criteria. Itu forward method. Okay, tapi yang paling yang paling simple adalah enter method. Okay, stepwise ni dia kena ada teori yang bukan stepwise. Backward method ni dia kena ada teori yang strong untuk pakai. Okay, strong theory. You have strong theory and then based on strong literature, you already identify. Okay, according to the list of IVs that you have, okay, which IVs that the most strongest variable or influence towards your DV. Kita dah identify dah. Okay, that's why kita boleh masukkan satu-satu. Okay.
Doktor, method tu cerita dekat data analysis bab 3, chapter 3.
Chapter 3, yes, chapter 3. Okay, so now go to our finding. Go to our output. So the first table that we have is the regression, the method that we use, enter method. Okay, so the model, the variables entered task mean, which is our IV. Then variable remove none. Okay, the method that we use is enter method. Okay. So it also indicate our DV, which is PB mean, philanthropic behavior. Okay, the second table model summary. So model summary ni will indicate the overall model. Tadi yang hypothesis, the earlier hypothesis is related on the overall model. Okay, so since there is only one independent variable, so this is the bivariate correlation. Untuk R value ni, so capital R ni, the way we read the R value is similar to the way we read Pearson product moment correlation coefficient. So R in simple linear regression similar to small r in Pearson product moment correlation. Okay, so R equals to 0.341. So that's why the value is similar. Okay, so R squared, okay, will indicate the amount of variance explained. Okay, R squared or coefficient of determination identify the proportion of variance in DV accounted for by IV. Okay, how much variance in DV explained by our IV. Okay, so in this case, we can say that 11.6% of the variance in philanthropic behavior is explained by task-oriented coping. Okay. Okay, so next one ni adjusted R squared ni is an accurate. Sebenarnya adjusted R squared ni it already went through a statistical adjustment, okay, in which it is more accurate compared to R square. Tapi the way we read adjusted R square ni is similar to the way we read R square. So that's why in articles you can see there are some scholars they prefer to report adjusted R square compared to R square. Okay. Dia buat some adjustment supaya value tu lebih accurate. Itu dibuat secara dalam sistem lah, dalam software. Okay. Next one. Okay. The ANOVA table ni will indicate the significance of the overall model. Okay. So it provide a result for overall regression model. So we refer to the F and significant F value. So F equals to 7.631, in which our significant value 0.008. Okay, so according to the result, our overall model fits the data or does not fit the data. Fits the data. Okay, since the significant F 0.008 lesser than alpha 0.05, so we can conclude that our regression model fits the data. What does it mean if, let's say, if we conclude that our regression model fits the data? What does it mean? What does it mean? It means that our IV significantly influence DV. Kalau kat sini kata significant, so we can know, we know that our IV significantly influence the DV. Ni dia susah sikit nanti bila when we enter the multiple linear regression, then you can see the actual function of this model. Sorry, the actual function of F and significant F. Okay, ni faham If the overall model indicate that there is a significant influence, the regression model fits the data, so then we conclude that our IV contributes significantly towards the DV. So now we want to see the individual contribution of our IVs toward the DV. Okay, so if we may recall our prediction equation, y equals to B naught plus B1 X1. Okay. So B naught, when we go to, we refer to the coefficient table. Okay, we refer to the coefficient table. Hold on. Okay. Mana saya punya button ni? Okay. Okay, so first y equals to B naught plus B1 X1. Okay, so we refer to the coefficient table. So now we have model, under model we have model 1. Okay, we have constant and then we have task mean. So task mean is our IV. So constant equals to B naught. Okay, so in the next column we can see that there are unstandardized and standardized coefficient beta. Unstandardized and standardized coefficient. Okay, standardized coefficient is used to interpret how much variance explained. Okay, standardized coefficient is used to interpret how much influence of our IVs toward the DV. How much variance in our DV has been explained by our IV. Okay, unstandardized coefficient is used in our prediction equation. So unstandardized coefficient is used in our prediction equation. Standardized coefficient is used to interpret how much variance in DV explained by the IV. Okay, T and significant T will be used to interpret either the influence is significant or not. Okay. Okay, so constant. So B naught ni, B naught equals to 2.457. This is the B naught. B1 equals to
0.316.
0.316. Okay. So then we transfer, we plug in into our prediction equation. It becomes y equals to 2.457 plus 0.316x. Okay. So what we can interpret based on this prediction equation? 1 unit increase in
Increase in Y.
y, x will increase by
0.316 unit.
0.316 unit. So this is how we can interpret this prediction equation. Okay, so now does our does task-oriented copying influence significantly toward the DV? So then we refer to the T and significant T. So T and significant T, make sure we use the task mean column. Kita guna row ni, row dia ni. Okay, so T equals to 2.762. Meanwhile, significant T equals to 0.008. So the result is significant or not significant?
Significant.
Significant. Because
Less than alpha.
less than
Alpha.
alpha. Okay, so see the significant T lesser than alpha 0.05, which is 0.008. So we can conclude that task-oriented copying contributes significantly to the DV, which is philanthropic behavior. Okay, so 95% confidence interval for B ni, lower bound, upper bound also can be used to make the decision. If 0 located within the range, so the result is not significant. If 0 located outside the range, the result is the result is significant. Okay, so to use lower bound and upper bound, so the decision is based on the location of 0. Okay, supposedly, so in this case, 0 since 0 located outside the range of 0.087 to 0.544, so we can conclude that the result or the influence of IV toward the DV is significant. Okay. Now, what about the standardized coefficient beta value, which is 0.341? Ni kebetulan tau. Ni kebetulan sama dengan ni Kebetulan. Okay, standardized coefficient beta 0.341. What we can conclude? We can say that 34.1% of variance in philanthropic behavior has been explained by task-oriented copying. Okay, 34.1% of variance in philanthropic behavior has been explained by task-oriented copying. Any question? Ada soalan? Kalau tak ada soalan, saya tanya. Why this value different with R square? Sedangkan cara kita baca, the way we interpret the R square is similar to the way we interpret the standardized coefficient beta. But why the value is different? We only have the task-oriented copying in our data set. Why? Why? Okay. For example, when we conduct a study on philanthropic behavior. So this is philanthropic behavior. Okay, so after completed our study, we figure out that, okay, in overall, only 11.6%, okay, 11.6% of variance in philanthropic behavior has been explained by task-oriented coping. So this is task-oriented coping. Okay. Okay, but within this 11.6% ni, okay, only 34%, 34.1% je. 34.1% out of 11.6% ni has been explained by task-oriented coping. So the rest ni, the rest of 65.9 considered to be error. Faham? Faham? Okay, faham tak? Tak faham. Nah, is it clear or not clear?
Betul yang residual tu
Yes, can be residual or error. Okay, so for example, again, when we conduct a study that to determine the association, to determine the influence of task-oriented coping and philanthropic behavior, we figure out that only 11.6% of variance in PB explained by TOC. So another 88% ni, 88.4%. Okay, another 88.4% has been explained by another variable. Which not been studied in our study lah. Faham Hani faham? The first one ni. Okay. So in total we have 11.6%. Okay, but after we go through, we further our analysis to see the individual contribution. Out of 11.6% ni, only 34.1% out of 11.6% of variance in philanthropic behavior ni, in which another 65.9 ni is an error. Okay, the actual influence only 34.1% out of 11.6. Faham tak? Yang ni sebenarnya bawah ni. So if let's say we transform into another pie chart, so 11.6% ni it becomes another pie chart of the contribution of task-oriented coping on philanthropic behavior. Okay, so ni contohnya this one akan jadi 100% which is equal to 11.6. But out of 11.6, only 34.1% je. The influence of task-oriented coping on the influence of TOC towards PB ni actually been contributed by task-oriented coping. Faham so selebihnya ni adalah error. Error in data collection ke, dia ada error lah, data collection, sampling. Okay, faham So that's why nilai kat sini tak sama dengan kat sini. Sepatutnya sama. Kalau in vacuum, dia sepatutnya dia akan sama. Faham Okay. Okay, so this is the APA format to present your summary ANOVA table. Dah, tak apa. Ini laju. Okay, so based on our finding earlier for the overall model, we reject the hash knot, and then because we said that the regression model fits the data at 0.05 or 0.01 depending on the alpha that you set for your study. Okay. Okay, this again, to interpret the coefficient of determination R square, it is referring to the amount of variance in Y explained by X. So the value of coefficient of determination ranges from 0 to 1. Smallest is 0, largest is 1. Meanwhile, the multiple correlation coefficient R in simple linear regression is similar to the way we read or interpret the correlation coefficient in Pearson product moment correlation. So it indicates the relationship between X and Y, and then the value range from 0 to 1. Okay, or the direction. Okay, for R value in simple linear regression, it does not indicate the direction, negative or positive. Okay, dia takkan indicate. Multiple correlation coefficient, it does not indicate the direction. It just indicate the value. Value sahaja, tak ada direction, negative or positive. Okay. Ini effect size. Okay, ini langsung. Okay, next one. Ini dah. Ini another example kot ni. Ini to report Tadi based on finding tadi lah diulang balik je. Okay, this one to report the effect size. Again when we report the beta and standardized beta and unstandardized beta, we just indicate either the result is significant or not. But to make sure to add more flavor into your report, you can also include the report on effect size. Effect size ni meaning that how much is the effect. Okay, effect of IV toward your DV. Okay, we know the amounts of variance, but now we want to quantify how much is the effect of IV toward the DV by reporting the effect size. So this is the calculation for effect size. Effect size equals to coefficient of determination divided by 1 minus coefficient of determination. So we plug in the value, coefficient of determination equals to 0.116. So 0.116 divided by 1 minus 0.116. So the result is 0.131. So by referring to cohort, saya tak ingat lah ni daripada mana sumber ni, nanti saya cari balik. Okay, by referring to this guideline, so 0.131 referring to the large effect size. 131 here 13, sini small, small. Dia belum sampai medium. Okay, 13. Oh, dia still the range of 0.02 ni. 0.02 until 0.14. Okay, so it is considered to be small effect size. Okay, so the influence. So small ni, kalau when we recall again the variance contributed by task-oriented copying tadi, which is only 34.1% or 11.6% tadi considered to be small, sikit. Out of 100%, it just contribute 11.6%. Okay, out of 11.6, it just contribute 34.1%. Very small contribution sebenarnya. Okay. Okay, so this is the prediction equation kita dah buat tadi. Okay, so if you are required to draw the prediction graph, so this is how you should draw the graph. Okay, so you locate the B naught equals to 2.457. Okay, and then you locate the equation on the straight line. Buat macam ni. Okay, kalau you all diminta buat So this is the interpretation. For every 1 unit increase in task-oriented copying, PB will increase by 0.316 units. Okay, so this is how you can draw the best fitted line in Ibm Spss. Okay, so to draw the best fitted line, you click on the graph, on the heading though, on your heading in your SPSS, you choose graph. Choose graph and then pick the legacy dialogues. Graph, legacy dialogues, and then choose scatter dot. Graph, legacy dialog, scatter dot. Done. And next one. You choose simple scatter. Under scatter dot box, in scatter dot box, you choose simple scatter. Next one, click define. Okay, for define, you choose PB min as for your y-axis, and then x-axis task min, task oriented min, task oriented copying min. Done. Okay, next one, click OK. Dapat? Then go to your output. Dah. Okay, go to your output and then anywhere in the graph, you double click. Anywhere on the graph. Double click. Okay, double click to activate. Okay, and then you under elements, you choose fit line at total. Jumpa? Fit line at total. Jumpa?
Jumpa.
Okay, next one. So go to the output again, then you can see that you already created your best fitted line. Dapat? Sama. Y equals to 2.46 plus 0.32x. Okay. Okay, so R square and R. Ni tadi dah. R square equals to 11.6. So we can conclude that 11.6% of variance in PB is explained by task-oriented copying. Okay, and then for R equals to 0.341. So there is a positive and low correlation between PB and TOC. So the direction ni I refer to the result that we got from Pearson product moment correlation analysis. Sebab dalam in simple linear regression or multiple linear regression, it will not indicate the direction. Okay. Ini pun sama. So this is the APA reporting style. So a simple linear regression was conducted to predict philanthropic behavior based on task-oriented copying. So a significant regression equation was found, which is F158 ni degree of freedom ni dengan sample size equals to 7.631, significant value 0.008 with an R square of 0.116. So prediction equation obtained from the result is Y equals to 2.457 plus 0.316 x1, where Y equals to philanthropic behavior and x1 equals to task-oriented copying. So according to the prediction equation, 1 unit increase in task-oriented copying results in 0.316 increment in philanthropic behavior. So further analysis on effect size indicated that the effect size is small. F square equals to 0.131. Kan? So ni contoh nak report. Okay, so this is APA table presentation style. So table 1, simple linear regression analysis between task-oriented copying and philanthropic behavior. Okay, so you in the model, in the table, you just report the individual contribution. Okay, in reporting, according to APA style, we just report the individual contribution. For the model fit, we report below the table. R equals to R, even though we do not read or we do not interpret the R value, but we just report. R equals to 0.341 R square we report and we interpret. F we report and we interpret. F and significant F ni we report and we interpret. Okay? And any questions so far before we stop? Cukup lah ini tu, berjam dah. Ni next week insyaAllah. Any questions so far?
Doktor, yang best fit graph tadi tu, yang tu kena letak kat appendix ke?
Best fitted draft, dia tak semestinya we locate in our appendix lah, but if you want to prove the slope, then you may report lah. Itu just optional lah. Rather than you report the finding in table, sometimes you want to report in terms of graph for individual contribution. Then you can see the distribution of data too from the illustration. Okay. Any other question?
Doctor,
Yes.
when we report for chapter 4, right, we report by the hypothesis, right? So the hypothesis and then the findings and then it's supporting literature review. Then we move to the second hypothesis, correct?
Okay. Chapter 4, we report according to okay. First, to me lah, I prefer to report according to the objective. First objective of the study. Okay. But if let's say you want to report you want to report the findings according to your hypothesis. For example, in your third objective, you have several hypotheses depending on the number of IVs that you have. Okay, so basically in terms of interpretation too, you can just interpret everything in one paragraph. Just interpret in everything in one paragraph. Next, in the next paragraph, only then you discuss. You can discuss according to paragraph lah, according to hypothesis, up to you. First, according to objective lagi senang lah. Objektif 1, objektif 2 start dan dengan demografi, objektif 1, objektif 2, and then objective 3, then then you divide according to your hypothesis. Okay? Okay, if there is no more questions, lagi, is there any more question? Tak ada dah. So saya lajukan part regression ni so that some of you may proceed with the analysis for your dissertation lah. Lepas tu baru saya akan cover balik dengan two-way ANOVA. Okay? So if there is no more questions, so we stop here. So thank you so much guys. So I thought still not too late to wish selamat Hari Raya everyone, and then enjoy your holiday lagi lah kalau ada holiday. Okay, so Assalamualaikum. Take care guys.
Salam.
Thank you, Doctor.
Salam. Thank you, Doctor.
Salam.
Thank you.